students, so those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us move ahead to the working of the NPN transistor of class 12 chapter 14 semiconductor electronics, materials, devices and circuits. Okay, so here I have drawn the NPN type of semiconductor. In the NPN type of semiconductor, we already know that N-type semiconductor is connected to the negative terminal, and here also N-type semiconductor is connected to the positive terminal. In order to work my transistor as an amplifier, we already know that the transistor should be connected in the forward active mode. So in the forward active mode, this region, this is my emitter to base region, should be connected in the forward bias condition. And in order to make it forward bias, this N-type semiconductor is connected to the negative terminal, and in order to make the collector to base region reverse biased, this N-type semiconductor is connected to the positive terminal. So here also I have taken the configuration as common base transistor. Okay, so here also the transistor which I have taken is common base. Okay, you can take any of the other configuration of the transistor also in order to explain the working of the NPN transistor. Okay, but here I'll be explaining the NPN transistor with the help of taking the configuration common base transistor. Okay, so this is my actual symbol of the transistor, and my transistor symbol actually looks like this. But in order to explain and in order to understand, I have drawn a simpler view of the transistor. In which the emitter is shown over here, base is shown over here, collector is shown over here. And since my emitter to base region is forward biased, so I have connected this N-type semiconductor to the negative terminal of the battery, and this should be reverse biased. In order to work as an amplifier, it should work in the active mode. So this should be reverse biased. So this N-type semiconductor is connected to the positive terminal of the battery. So voltage across the emitter to base voltage is taken less as compared to the collector to base voltage. Collector to base voltage is greater. It is having higher potential. Collector to base region is having higher potential than the emitter to base region. Now what will happen as soon as I will connect my batteries over here? So what will happen, here this is a negative terminal. Since the emitter is heavily doped, what is doping? We have already seen it. Doping enhances the conductivity. So there is a lot of conductivity in this region. So my electrons will start moving from the battery and to the emitter. It will start moving to the emitter. Now we already know that the flow of current is opposite to that of the flow of electrons. So my electrons are moving in this direction. So my current that will be constituted to the emitter will be moving in this direction, which I have already been shown over here. So my current is in this direction. Okay. So my current is in this direction, IE. Okay. Now my electrons are over here. So outside till outside my electrons are moving like this. Then they enter the transistor. And inside the transistor, again there is an N-type semiconductor over here. So electrons are then moving ahead towards the base. The base is P-type semiconductor. It is very lightly doped. In the N-type semiconductor, the majority carriers are the electrons and the minority carriers are the holes. Okay, so the electrons start moving towards the base. The base is the P-type semiconductor. Base is having the majority of the carriers as the holes, but the minority of the carriers as the electrons. So, but my base is very thin. It is very thin and it is very lightly doped. So what will happen? Very few electrons will get recombined. Very few electrons will be able to recombine. About 2% to 5% of the electrons only will be able to move, will be able to recombine and get neutralized. Okay, and rest of the electrons will start moving towards the collector region, and rest of the electrons will some of the electrons will start moving towards the collector region, and the rest of the electrons will constitute a current which is known as the base current. will constitute a current which is known as the base current. So now my base current, these are the electrons moving over here in the opposite direction, and the current will be moving in towards the transistor, will be moving inside the transistor. Okay, so over here now the collector is, now the electrons move towards the collector. Now collector is where collector potential is reverse biased, and the reverse biased voltage is very much greater over here. That means the electrons will get attracted towards this positive this positive terminal of the battery. The electrons will be attracted towards the positive terminal of the collector to base terminal positive battery. Okay, positive terminal of the battery. So all the electrons will be attracted towards this terminal, and they will again start moving towards the this terminal. As soon as the electron reaches the terminal, at the same instant next electron from this terminal, from the negative terminal of the emitter to base region, the negative terminal of the emitter to base region will start moving ahead towards the emitter. As soon as the electron reaches the electron which reaches towards this terminal, at the same instant from here the electron will start moving towards the emitter region, and as the electrons have moved towards this region, my collector current will be constituted in the opposite direction, in this direction. So at each and every step I am getting my collector current, at each and every step I am getting my base current, and at each and every step I am getting my emitter current. So if I see the collector current, base current and emitter current, a relationship I am getting over here. The relationship is that IE is equal to IB plus IC. Okay, so my collector current is equal to the sum of the base current constituted as well as the collector current constituted. So my emitter current is equal to the sum of the base current as well as the collector current. Why so? Because this current is moving away from the transistor and these two currents are moving towards the transistor. So I'll be getting the sum of these two currents, and that will be equal to the IE current. So in this type of transistor, in this type of NPN transistor, my flow of current is due to the electrons both in the internal as well as external. There is the flow of electrons only. This is the external part of the transistor in which the electrons are flowing, as well as this is the internal part of the transistor in which the electrons are flowing. So the movement of electrons is only there, and that is only constituting my all the three currents, and the relationship which I am getting over here is IE is equals to IB plus IC. So this was the working of the NPN transistor. In the next section we will be studying about the working of the PNP transistor. Okay, so thank you. So please subscribe my channel, please share my videos, and please, if you have any doubt, you can ask me in the comment section. Thank you.